let's begin with the laws of motion. So now, first of all, let us see Newton's 3 laws of motion, and then we'll see rest of the things, right? So first of all, let's see Newton's first law. So what is Newton's first law? Every body continues to be in its state of rest or of uniform motion along a straight line unless it is acted upon by an external unbalanced force. So if body is at rest, it will remain at rest. If body is moving with uniform velocity, it will keep on moving with uniform velocity till the time there is no external unbalanced force acting on the body. Okay, if body is at rest, body will remain at rest. Body is moving with uniform velocity, it will keep on moving with uniform velocity till the time there is no external unbalanced force acting on the body. This is very simple law, right? So for an example, suppose we have this wooden block resting on a floor. Okay, so now there is definitely one force acting on this block, which is force due to the gravity, right? So force due to the gravity is acting downwards. Now if there was only that force, then what could have happened? So block, it would have moved down, okay, inside the floor, but it doesn't happen. So according to Newton, there must be another force, okay, which is balancing this one, right? So see, actually in Newton's first law, the seeds of Newton's second law and third law, everything is there. Okay, so now if unbalanced force is there, then what will happen? The body, if it is at rest, it will start moving, right? It will start accelerating. Even if it is moving with uniform velocity, if there is unbalanced force acting on body, what will happen? It will accelerate. So now there is a force due to this floor, which we call normal reaction, which balances force due to the gravity. Okay, so then normal reaction is acting upwards, force due to gravity is acting downwards. Okay, that is weight of the block is acting downwards. So these two balance each other, and total force on the block is 0. That's why its velocity is 0. That means it is at rest, right? So it remains at rest. So this is the Newton's first law. Okay, this thing is clear? Yes, no? All right, so this is Newton's first law. So what does it say? That if sum of all forces acting on the body is equal to 0, okay, and force is a vector quantity. So see how I have written this. So summation of k goes from 1 to n, k goes from 1 to n of fk bar is equal to 0. So it is equal to what? F1 bar plus F2 bar. Suppose there are n number of forces acting on the body. If you add them all, okay, vectorically, then if net force is acting on the body is equal to 0, then what will happen? So according to Newton, if body is at rest, it will remain at rest. If body is moving with uniform velocity, it will keep on moving with uniform velocity, right? And so if net force acting on the body is 0, then we say that the forces are balanced. Okay, and if net force acting on the body is non-zero, then we can say it is unbalanced. So if net force is 0, then velocity will not change. Okay, state of rest is just state of 0 velocity, right? Okay, so if net force is 0, the velocity will not change. If net force is non-zero, then velocity will change. This is the Newton's first law. Okay, very simple. All right, so now this thing that we saw just now, this is known as a free body diagram. So what is a free body diagram? If you draw all the forces acting on the body, if you take some body, okay, draw it or draw it symbolically. Symbolically means just suppose I draw a square like this and I say that this is a block. I just draw a square like this or a circle like this and I say that this is a man. Okay, so that is symbolically drawing a body. Anyways, so we don't have to draw the body, okay, per se. We just have to represent it, okay, by some simple diagram. Okay, and then we have to include all the forces acting on that body. That is the free body diagram. And then we don't need to include, don't need to, we should not include the forces due to the body. Okay, just include, just draw all the forces acting on the body. So then in this example we have normal reaction which acts upwards, force due to the gravity acts downwards, and since body doesn't seem to be moving, the net force must be equal to 0. So normal reaction plus this force must be equal to 0. So that gives us normal reaction is equal to what? Mg. Right, this thing is clear, everyone? Okay, then see another simple example. Now suppose we have this is a rigid support. Okay, you can think of it as ceiling of your home, and then there is a string, a rope attached to that ceiling. Suppose it's hanging from the ceiling, and you connect some metal ball, okay, to the other end of that rope. Now the gravitational force will be acting downwards, so there must be another force which balances that, because the ball doesn't seem to be moving or accelerating upwards or downwards, right? So the force must be balanced. So there is another force. So what happens is, see, the weight of that ball, it acts downwards. Okay, weight of the ball acts downwards, and that string, because of that weight, it gets stretched, and because of that stretching, there is a force developed in the string, and that is known as tension in the string. Okay, that is known as what? Tension in the string, right? So tension in the string will be acting upwards. Tension in the string acting on that ball, okay, it will be acting upwards. Okay, so now this tension and gravitational force, they will balance each other, and therefore T is equal to mg. Right, this thing is clear? Okay, good. Right, so then now where does this tension come from? So let's just talk about it a little bit. So inside that string or anything, any body, there are atoms or molecules, right? There are atoms or molecules. So these are atoms or molecules. Now there will be millions of atoms or molecules, but we don't need millions to understand the tension. So there are bonds within these atoms or molecule. So they are called as interatomic or intermolecular bonds. So let's say intermolecular. Okay, and the structure is like spring. Okay, so now what happens is, when you stretch a body, or let's say a rope, what will happen? The molecules, they will go away from each other, right? And these molecules want to sit at a fixed distance, which is known as equilibrium distance. Now why is it so? So the reason behind that is, atoms have positive and negative charges. Okay, so nucleus is there, which is positively charged, then electrons are there surrounding the nucleus, which are negatively charged. Then there is another atom which is positively charged, then there are electrons which are negatively charged. So now there will be force due to this atom. So see, there will be force due to this positive charge on the second atom. Okay, force between positive and positive charge will be repulsive force. Force between negative and negative charge of electrons, it is repulsive force. But force between these negative charges and this positive charge, and force due to this negative charges and this positive charge, it will be attractive force. So now they will like to sit at a particular distance where all these forces are balanced. Okay, so that distance is known as equilibrium distance. Okay, the distance between molecules, it is known as equilibrium distance, right? Distance between atoms or molecules. So now if you increase that distance, what happens is, the force between molecules becomes attractive force, and if you decrease the distance, it becomes repulsive force. Okay. So when you stretch a string or a rope, what happens? The distance between these atoms or molecules, it increases a little bit. Okay, and because of that, what happens? These molecules or atoms, they want to restore that distance, so they start attracting each other, and that's why now these molecules, they will pull on these molecules. These molecules also, they will pull on these molecules. So because of that, an internal restoring force is generated, and that is known as, that is the origin of tension in the string. Right, this thing is clear? Yes, no? Okay, good. So that's the origin of tension in the string. All right, now after that, let's see very small problems based upon the free body diagram, or let's say Newton's first law. So see here, this is again a ceiling of a room, and these are two strings. Okay, these are two strings attached like this. There is another string, okay, and a weight hangs from this third string. Okay, and now suppose this angle is 120 degrees, this angle is also 120 degrees, and this angle is also 120 degrees. So now weight of this ball, it is equal to mg, right? Weight of the ball is equal to mg. Okay, and it is acting downwards. Now suppose its mass is equal to 5 kg, right? Mass is equal to 5 kg, and this theta and this theta is equal to 30 degrees. Okay, so if this is 120, that means this angle would be 60, this would be 30, and this is 90, right? If this is 30, then this angle has to be 60 degrees. Okay, because it will be 30, 60 plus 90, so sum of three angles in a triangle should be equal to what? 180. Or you can say it this way also, this is 30, 30. Okay, so that's 60 degrees plus 120 degrees, that's 180, right? So then we want to find out tension in this string. How do we find out? So if you remember, we had seen one rule known as sine rule. Okay, so see, because this is a symmetric diagram, I can say tension in this string and this string would be equal. Okay, so if I say tension in this string is T, tension in this one will also be equal to T, and now I want to find out the tension. So what I will do is, so I have this force, because all these three forces are in equilibrium. Equilibrium means sum of these three forces is equal to what? It is equal to 0. Okay, because body is at rest. So if body seems to be at rest, then sum of all forces acting on the body must be equal to what? 0. So sum of those three forces is equal to 0. So now what happens? See, this force acts downwards, right? So how do we apply the sine rule? It is this force W divided by sine of the angle between other two. So that's 120 degrees, right? Then take this one. So this force divided by sine of the angle between the other two, that's also 120 degrees. So one force divided by sine of the angle between other two is equal to take any other force divided by sine of the angle between other two. So they should be equal. So therefore I say that T divided by sine of 120 degrees is equal to W divided by sine of 120 degrees, and then in denominator it's sine 120, sine 120 only. So it gets cancelled out, and therefore you have T equals to W. Okay, so tension is just equal to mg. Tension is equal to weight of this string, sorry, weight of the ball. This thing is clear? Yes, no? All right, so now this is one way of solving this. So if there is equilibrium, we can just apply the sine rule and we can find out the answer quickly. Otherwise, what do we need to do is, see, the second method is also shown here. So see, now there are these two strings, so there is tension in this string and there is tension in this string also. This angle is theta, right? So what I will do is, I will resolve these two tensions in two components. So what are those two components? One would be horizontal component, one would be vertical component. So this angle is theta, so this angle has to be equal to theta, okay, because these are parallel lines and this is an intercept, so these are alternate angles, okay, and alternate angles are equal, so this angle has to be theta, right? So then this angle is also equal to theta. So now I want to resolve this tension. So we remember that the component through the angle is a cos component, so this is a t cos theta. Component away from angle is sine component, so there would be 1 t sine theta due to this tension. And again, if you talk about this another tension, then component through the angle is t cos theta, it's t cos theta. Component away from angle is t sine theta, right? So the t cos theta and t cos theta, they are directed opposite to each other, so this one and this one get cancelled out, so there is no force in horizontal direction, right? Because this t cos theta and t cos theta, they get cancelled out. And then you have this tension, it's one component in vertical direction, it is t sine theta, so there is 1 t sine theta due to this one, 1 t sine theta due to this one, those two get added up and you have 2 t sine theta, right? 2 t sine theta, so that 2 t sine theta and the weight must be balanced, okay. So then you have 2 t sine theta is equal to mg, and what is theta? Theta is equal to 30 degrees. So what is sine of theta? That is equal to half. So 2t multiplied by half must be equal to mg. So the 2 gets cancelled out. So once again you get t equals to mg. Right? This thing is clear. Okay, good. So now following completely different procedures, you found the answer and it matches. That means both procedures are legitimate. Okay, you can do this way or this way, but doing this way is, it will take a little bit of time, right? It will consume some time. So if you remember sine rule, you can always apply it. If there is an equilibrium, if sum of three vectors is equal to 0, just apply the sine rule. Okay, if angles are known, right? Because this is very quick. Okay, good. Then let's move on to the Newton's second law. Okay, by the way, I just need to tell this. So before Newton, now people used to believe in the ideas of Aristotle. Okay, so there is one complete section dedicated to Aristotle's policy in NCERT, but there are no questions asked based upon that. So what is Aristotle? What was Aristotle's thinking is that, so see, for an example, in our day-to-day life, okay, if we ride on bicycle, we need to keep on pedaling the bicycle. Okay, so we need to keep on applying a force, otherwise it stops, right? But now we know it stops because of some force, that is the frictional force. But in those times, in the times of Aristotle, these forces were not known, like friction and all. These forces were not known. So they used to believe, Aristotle used to believe, that you need to keep on applying a force to keep the body moving in uniform motion. Okay, so his thinking was bodies have tendency to stop, and if you don't want them to stop, then you need to keep on applying force. Okay, so that was his thinking, so which is wrong basically, right? So now we know that to keep a body moving in uniform motion, we don't need a force, we need net force equal to 0, right? So what pedaling does to a bicycle is it balances the frictional force. Okay, so now if you just balance out the frictional force, what happens? The bicycle keeps on moving with uniform velocity, right? So net force in that case is also equal to 0. Okay, so that's one thing. And this Newton's first law, it was not given by Newton, it was given by Galileo. Okay, so Galileo did lots of experiments. You can search them on Google, right? And he was the first one. He gave us the Galileo's law of odd numbers. Okay, so he did lots of experiments on, let's say, balls released or bodies released from some heights, then bodies released on inclined planes, and he studied what distance do they cover, etc., etc., and he came up with this law, right? But Newton gave us the complete framework of mechanics. That means he gave second law, third law, and he derived lots of things. Okay, he gave the law of gravity also at the same time, more or less on the same at the same time. So this law is also named after Newton. Okay, but this idea was given by Galileo. Okay. Oh. And that's why Galileo is called as father of physics, because earlier to Galileo nobody was doing experiments, so they were just thinking, oh, this thing might happen. Okay, and like Aristotle, so so Aristotle was great, but nobody used to do experiments, and Galileo was the first one who framed the laws by doing experiments. Okay, and that's why he is named as father of physics. So all right, so just for the sake of information and just to pay some respect to Galileo, okay, I just wanted to tell this, right? All right, so this is Galileo's law basically. Okay, so let's move on to the Newton's second law. Okay, so now what does the Newton's second law say? So what does Newton's first law say? First law says that if net force acting on the body is 0, total force acting on the body is 0, then what happens? If body is at rest, it remains at rest. If body is moving uniformly, it will keep on moving with uniform velocity, right? That is first law. So now what will happen if you apply the force? What will happen? That velocity will change, right? Newton's first law say velocity remains constant if net force is 0. So if net force is not 0, total force is not 0, what will happen? The velocity will change. But that velocity changes differently for bodies having different masses. Okay, if there is a heavy object, its velocity will not change much. If there is a light object and you exert same force on that object, then its velocity will change with huge amount. Okay, and that's why there is a quantity called as momentum. Now what is momentum? It's product of mass and velocity, so that is important. Okay, right? So Newton's second law says that the rate of change of momentum of a body is directly proportional to the external unbalanced force acting on a body, and it takes place in the direction of external unbalanced force, right? So Newton's second law says that rate of change of momentum of a body, rate of change in momentum, you can say, of a body is directly proportional to the external unbalanced force acting on the body, and it takes place in the direction of that force. So suppose P1 bar is the initial momentum of body, P2 bar is the final momentum of body, and you exert some force because of which this change in momentum happens. Okay, so F bar is suppose the average force acting on the body, right? And it acts in this much time, delta t. So what is delta t? Delta t can be written as t2 minus t1. Okay, t1 is the initial time and t2 is final time. So delta t is t2 minus t1. Then Newton says that this force is proportional to change in momentum divided by time. He says rate of change of momentum is directly proportional to the force, right? And then you remove this proportionality sign and put an equality sign, then a constant will come. Okay, a constant will come, and then you have force is equal to k, some constant k, multiplied by P2 bar minus P1 bar divided by delta t. So now the value of this constant, we take it as 1, because this was for the first time that some law, some formula was given for the force. Okay, it was introduced by Newton. So we need to keep the things simple. We don't need to complicate them. Okay, unnecessarily at least. So that's why we keep this constant equal to 1. So therefore you have force is equal to what? P2 bar minus P1 bar divided by delta t. So change in momentum divided by time. Right, this is the average force in this time interval. Okay, what is this? This is the average force in this time interval. This thing is clear. Okay, good. Then good. Then so we have force is equal to average force is equal to P2 bar minus P1 bar divided by delta t. This thing can be written as P2 bar can be written as mass of body multiplied by its final velocity, right? Okay, and P1 bar can be written as mass of body multiplied by initial velocity. So generally we denote final velocity by v and initial by u, and divided by the time is delta t, or you can say t2 minus t1. Then you can take mass common. Okay, and then we have v bar minus u bar divided by time difference delta t, or t2 minus t1 you can say. So what is this thing? This is change in velocity divided by time. So this is the average acceleration. Okay. So we get force is equal to mass multiplied by acceleration. So here we have assumed that mass of the body remains constant. Okay, here we have assumed that mass remains constant. Right. So if mass remains constant, m is constant, okay, so this thing is clear. Force is just mass multiplied by acceleration. Okay, good. Then now this was average force. This is the average force. Okay, we just took the difference between final and initial momentum and we divided that by time. Now we know how to go from average quantity to instantaneous quantity. How to go from an average quantity to instantaneous quantity? Just take derivative, right? So what would be an instantaneous force? So instantaneous force is rate of change of the momentum with respect to time, dp bar by dt, rate of change of momentum with respect to time. Okay, so what is momentum? Momentum is mass times velocity. Then we apply the product rule of derivatives. So what is that? Take derivative of first term, keep second term as it is, right? So take derivative of m, so it is dm by dt, keep second term as it is, so v bar as it is, plus then keep first term as it is and take the derivative of second term, so dv bar by dt, right? So this is equal to dm by dt into v bar plus m into dv bar by dt is acceleration. So the force, if we consider an instantaneous force, it has two terms. It has got two terms. First one is dm by dt multiplied by v bar, and the second is mass times acceleration. So now if mass is constant, then we know that derivative of constant is 0, so this first term will vanish. So we have force is equal to mass into acceleration, like we discussed here, if mass remains constant. Okay, and second case is if velocity is constant. If velocity is constant, then we need to take f bar is equal to dm by dt, mass is changing, velocity is constant, so dm by dt multiplied by v bar. right? This thing is clear, everyone? Okay, so force is not just mass into acceleration, it will have these two terms. Then if nothing is constant, then you need to use this formula, but at max they can ask you what is the instantaneous force. So at max they will ask you about this formula, there will not be any question based upon this thing. Okay, that is too advanced. All right, then let's talk about the Newton's third law. To every action there is always an equal and opposite reaction. So actually to every action there is always an equal and opposite and simultaneous reaction. Okay, so what is this action and reaction? Okay, so there is no action film going on, right? So what is an action? It is the force exerted by one body on another body. And what is the reaction? So reaction would be force exerted by the second body on first body. Okay, so now just to give an example, suppose you slap somebody. Okay, this is the action. If you say this is an action, what will be its reaction?
They slap again.
Oh, no, I was not expecting this. Anyways, so all right, so I'm okay. I don't believe in these things. I mean, I'm follower of Gandhiji, but okay. So suppose this is an action, right? Then reaction has already happened. So what is the reaction? This is the force exerted by one body on second body, and the second body, it is exerting force on the first body at the same time. Okay, that's action and reaction, right? So to understand it, now you can take an example of this thing. This is a punching bag. Suppose you punch on the punching bag. What happens? The same time, the punching bag, it hits your hand, right? Okay. Or right now itself, you can just try. You can just punch on the wall. Okay, near you. So now this is the action and this is the reaction. It's happening at the same time. So when you slap somebody, at the same time the reaction is also happening. So according to Newton, so what is this action and reaction? Action is a force due to first body on second body, and reaction is force due to the second body on first body. And they are equal and opposite and also simultaneous at the same time. They are happening at the same time, right? Then the action and reaction always appear in pairs. Okay, they will always appear in pairs, right? So it will never happen that there is only action, there is no reaction. The action and reaction act on different bodies. Okay, any of the two forces can be called as an action or reaction, and action and reaction don't cancel. Okay, action and reaction, they do not cancel. Any of the two forces can be called as action and reaction. It's not like this is an action and this one is reaction, because they are acting simultaneously, right? This thing is clear? Yes, no? All right, so now let's come back to the example that we had taken at the beginning. So the example was, for an example, suppose this is me and I am standing on a floor. So can you tell me what's the action here and what's the reaction? Can you tell me what is the action and what is the reaction? Mg and normal reaction. But what is Mg? It is force due to what? Force due to the man. Good. force due to the man. So see here there are two action reaction pairs. Okay, so one is this man is pulled by gravity downwards, so man can't stay there, right? If the floor was not there, the man would have moved downwards with an acceleration equal to g. So he is hitting, or he is pushing, you can say, because he is being pulled by gravity, he is pushing the floor by the force of mg, right? He is pushing on the floor by the force of mg, and the floor also reacts, it applies an upward force which is equal to mg. So here there are two pairs, one is two action reaction pairs. So first one is N normal reaction and force due to the man, force due to man on floor and force due to floor on man, and I will just call it N. Can you tell me what's the second action reaction pair? The second action reaction pair here. No, man is just standing over there. There is no friction. He's not trying to walk. Okay, let me tell you. Second one is force exerted by gravity, or you can say earth, on the man, and force exerted by man on earth. They will be equal and opposite. Okay, so force due to earth on man and force due to man on earth. So earth is pulling this man downwards with force equal to mg. Man is also pulling on the earth. Okay, man is pulling the earth upwards with force equal to mg, right? So these are two pairs. This thing is clear? Okay, everyone? Good. All right. So then next is a motion of the rocket. Now this is a simple, I mean a real rocket and its motion, rocket propulsion, etc. It will be complicated, but the question that will come in NEET, they like this question, so it's very simple. What is this thing? So suppose you have a rocket. Now how does it move? So suppose it's resting on earth. So what happens is fuel is burnt here, okay, in this fuel tank, let's say. So because of that, now there are some openings over here, okay, at the bottom of the rocket, and the burnt fuel, it comes out as exhaust gases. Now this is combustion chamber and the fuel is burnt. Now there is opening in only one side, okay, that is in downwards direction. So you can say that rocket is exerting a force downwards. Okay, these gases, exhaust gases, they are forced to move downwards only. So this is the force exerted by the rocket on these gases, it is downwards. Now these exhaust gases, they will also exert an equal and opposite force, so that force will be acting upwards. Okay, so this thing is clear? Yes, no? Okay, so the exhaust gases, they exert a force on rocket and it's upwards. So when fuel is burnt, what's happening here? Some mass of the fuel is decreasing. So there is change in mass, right? There is change in mass, and we'll consider that it is moving with constant velocity. So then what is the force on the rocket? So force on rocket due to this exhaust gases, due to this change in mass, it is known as upthrust. Okay, this is called as an upthrust. So what is upthrust? It is force, okay, due to exhaust gases acting on the rocket, and it is just equal to dm by dt multiplied by v. Okay, it's just equal to what? Dm by dt multiplied by v. Right, this thing is clear? Yes, no? Okay, good. So now let us see some examples based upon these things, and then we'll come back. So first one, the linear momentum of a particle varies with time as p equals to a plus bt plus ct square, then which of the following is correct? So this is very, very simple question. Velocity of particle is inversely proportional to time. So can you say that? It can't be. Okay, see the reason. P is equal to what? It is mass times velocity, right? If mass is constant, then what is, if mass is a constant, right, m times v is a plus bt plus ct square. Mass is constant, then v is proportional to what? These things, this factor. Okay, it's proportional to a plus bt plus ct square. So that is not true. Displacement is independent of time. It can't be, because what is velocity? Dx by dt. Then you move time on that side and you integrate it. So displacement will also depend on time, because velocity is time dependent. Okay. If velocity was constant, then you could say displacement is independent of time. No, actually in that case also, sorry. If velocity is constant, then also displacement would be a function of time. It is v times t, right? Okay. Next is force varies with time in quadratic manner. Force is dependent linearly on time. So to check this, what do we need to do? We need to take derivative of this thing. Okay, so we have momentum equals to a plus bt plus ct square. Let's take its derivative. So we know f is equal to dp by dt. So that is d by dt of a plus bt plus ct square. Take its derivative. So what do we get? Derivative of a is 0. Derivative of this thing is what? T only. Sorry, derivative of this thing is b only, and derivative of this thing is what? It is 2 times ct. Okay, you can take b outside. Derivative of t is just dt by dt is 1, so that's why this is b. And derivative of this thing, you can move c outside. Derivative of t square is 2t, so that's why derivative of this term is 2ct. So f is equal to b plus 2ct. Okay, so now which one is correct? Option C or option D? Yeah, it's option D. Right, option D is correct. Good. Okay, so now it is linearly dependent on time. So you know that equation of a line y is equal to mx plus c. Okay, so I will write it as y is equal to c plus mx. So what are the two variables here? So you can compare y with force, right? So suppose your y is force, and this constant is b here, and force depends on time. So time is a variable. So here x is analogous to t. So what will be the slope of this thing? If you plot a graph between force and time, the slope is equal to 2c. This thing is clear? Yes, no? Okay, good. All right, so this was a very simple question. Option D is the answer, right? Okay, let's see next one. A football player is moving southward and suddenly turns eastward with the same speed to avoid an opponent. Okay, he is moving southward and then moves eastward. The force that acts on the player while turning is. Tell me. Anyone? Option D, along southwest. Okay. All right, let's check. So football player is moving southward like this, in this direction, and he is turning towards east. Okay, so let's say this is his initial velocity vi, this is the final velocity vf, right? So to find out acceleration, I need to find out vf minus vi, right? So if I just draw this thing, east, west, north, south, this is the initial velocity. Let's take this color. This is initial velocity. This is final velocity, right? This is vi, this is vf bar, let's say. Then I want to add vf and minus vi. Minus vi would be directed like this, right? This is minus vi bar, because to find out acceleration, what is acceleration? It is final velocity vf minus vi divided by time. Okay, and force is just mass into acceleration. So whatever is the direction of acceleration, same is the direction of force. So vf minus vi would be directed like this. The resultant would be directed like this. Which direction is this? This was south, this is north, this is east, and this is west. This is northeast, right? Okay, this is clear. This is from NEET 2023. Okay, so simple question, no calculation required. Okay, but concept is checked. Okay, good. Let's see next one. A particle moving with velocity v is acted by three forces shown by the vector triangle PQR. So this is one force, then this is second force, this is the third force. The velocity of the particle will, tell me, change according to the smallest force QR, increase, decrease, remain constant. Everyone? Yeah, it will remain constant because sum of these three forces is equal to 0. Okay, sum of these three vectors is equal to 0, right? How is it 0? So you can think of these vectors as displacement also, because whatever is applied applicable to displacement, okay, vector rules, they are applicable to force also. So you can think of it like this: you start from this point, you go till here, then you go from there to here, then from there to here. So what is your net displacement? Net displacement is 0. Okay, similarly, if you apply this much force in this direction, then this much force in this direction, then starting from there, this much force in this direction, so net force is also equal to 0. Okay, that's simple, right? Let's see next one. Three forces acting on a body are shown in the figure. To have the resultant force only along y direction, the magnitude of the minimum additional force needed is, tell me. You want the resultant force only in y direction. Okay, only in y direction. Where do you need to apply the force, additional force, in x or y direction? Tell me. X direction, right? So see, here we want resultant force in y direction only, so we need to balance force in x direction. Okay, so let's just resolve this. So this 4 Newton I will resolve, and this 1 Newton I will resolve in x direction. So the x component of this one would be 4 sine of 30, right? This is 30 degrees. So if I want component through the angle, it will be cos component. Away from angle is a sine component. So it is 4 sine 30, and component of this one in this direction is 1 cos of 60, right? So cos 60 is also half. So what is the net force? Therefore the net force in x direction, net force in x direction, net force in x direction is equal to what? It is 4 sine 30 minus 1 cos 60. So that is 4 times half minus 1 times half. Okay, so this is 3 minus half, sorry, 2 minus half, so it's 3 by 2, or you can take half common. 4 minus 1 is 3, so 3 by 2. So net force is 3 by 2, that is 1.5 newtons. It is acting towards left, so you need to apply a force of 1.5 newtons as shown in the figure. That force is x towards right. Okay, then the net force in x direction will be balanced, right? So this is very simple. All right, this thing is clear. Very simple question, right? Okay, let's see next one. A stone is dropped from height h. It hits the ground with certain momentum p. If the same stone is dropped from height 100% more than the previous height, then the momentum when it hits the ground will change by. Tell me. If you drop a stone from height h and then you drop it from 100% more height, so what is change in momentum? This is the question. Okay, let's solve this. So you can say P1 is equal to mass times velocity. And what is velocity? It's equal to m multiplied by, when an object is dropped from some height, the velocity is what? Root 2 gh. Okay, what will be P2? P2 is m multiplied by root 2 g multiplied by 2h, because it is dropped from a height which is 100% more than the previous height. So it is root 2 g multiplied by 2h. 100% more height is twice, right? So now let's take P2 by P1. So if we take P2 by P1, what do we get? That mm will get cancelled out, and it is just ratio of this thing, root 2 gh into 2 divided by root 2 gh. So that root 2 gh and root 2 gh also gets cancelled out, and it is just equal to root 2. What is root 2? It's 1.41. So P2 by P1 is 1.41. So how much is P2 then? So P2, you can say it's 141, sorry, 1.41 times P1. Or if you want percentage, then if P1 is 100, then how much would be P2? It will be 141. That means it will be 41% greater than that of P1. right? It is 41% greater than that of P1. So this is the answer. Right. So this one too was very simple question. Okay, let's see next one. A body under the action of force, this is the force, acquires an acceleration of 1 meters per second square. The mass of this body must be, tell me. How much would be the mass of this body? So you have force is equal to mass times acceleration if you want magnitude. Option C. Okay, let's check. So mass is 1 kg. That means magnitude of acceleration would be equal to magnitude of force, right? So let's just find out magnitude of force. What is magnitude of force? Square root of fx square plus fy square plus fz square, right? So that is equal to square root of 6 square plus minus 8 square plus 10 square, and that is square root of 6 square is 36, 8 square is 64, this is 100, so it's 100 plus 100, 200, square root of that, or you can just say 2 times 100, so 10 root 2, right? Square root of 100 is 10. So force is equal to 10 root 2, mass is 1. So what would be the, force is equal to 10 root 2, and what is 1? Acceleration is 1, right? Acceleration is 1. That means mass is equal to 10 root 2. Okay. So this is very, very simple. All right. Very good. Very simple question. Let's see next one. So a force vector applied on a mass is represented as F bar is equal to 6 I cap minus 8 j cap plus 10 k cap and accelerates with 1 meters per second square. What will be the mass of the body? So it is the same question, right? It's the same question, but this is from 1996. This is from 2009. So you don't know where do they take the questions from, right? So the answer is 10 root 2. So they could just take little bit of effort, just change the value. At least they could change this thing as 2. Okay, so mass would have been what? Force is equal to mass times acceleration. Yeah. So if acceleration is twice, then mass would be half. So 5 root 2. Anyways, let's move on to the next question. So a 600 kg rocket is set for a vertical firing. It is kept and it's set for vertical firing. If the exhaust speed of the exhaust gases is 1000 meters per second, the mass of the gas ejected per second to supply the thrust needed to overcome the weight of the rocket is, tell me. The mass of the gas ejected per second. So you need to find out dm by dt. What's dm by dt? To supply the thrust needed to overcome the weight of the rocket. So let's take the rocket. Alright, so this is our rocket and we want to support weight of this rocket. That means how much weight must be, how much force must be acting, how much must be the upthrust. This force due to the exhaust gases, okay, which is acting upwards, must be equal to what? mg. Right, this force is equal to mg. It supports weight of the rocket, no? So that force must be equal to mg. So you have this force equals to what? What is the force due to exhaust gases? It's dm by dt multiplied by speed of the exhaust gases, right? So what's that? you need to find out dm by dt. Okay, you want to find out dm by dt. Just put force is equal to mg, because you are supporting, not you, that exhaust gases, they are exerting an upthrust. That upthrust is supporting what? Weight of the rocket. That upthrust must be equal to mg. Okay, so mg multiplied by dm by dt times v, and therefore dm by dt just equal to mg divided by v, right? So what is mg? This is 600 kg rocket, so 600 times 10, let's take 600 times 10 divided by 1000. Okay, so that is equal to 6000 divided by 1000 means 6 kg per second. This is the answer. Okay, this one is clear? Yes, no? Right, good. Now let's see next one. In a rocket, fuel burns at the rate of 1 kg per second. This fuel is ejected from the rocket with a velocity of 60 kilometers per second. This exerts a force on rocket equal to. Tell me. This is very simple. This exerts a force equal to dm by dt multiplied by v. So dm by dt is given, right, 1 kg per second. V is given, speed of the exhaust gases is 60 kilometers per second. Okay, so dm by dt is 1. This is 60 kilometers per second. We need to convert it to 5 by not 5 by, we need to convert it to meters per second, and that is multiplied by 5 by 18, right? Okay, so I'm just, my tongue is moving ahead of my mind, or I don't know, right? This thing is clear? All right, so 60 by 18, how much is this? 6 3s are 18. Okay, so this is 3, then you have 50 divided by 3.
So it's already in kilometer per second.
Oh, it's kilometer per second. Sorry, I thought kilometer per hour. Okay, so then 60 kilometers per second, then you need to just multiply it with 10 raised to 3. Good. Okay, you need to convert it to meters per second, right? So kilometers to meters, that's why you multiply by 10 raised to 3. So therefore it is 60 into 10 raised to 3 means 60,000, right? Yeah, 60,000 Newton. So the answer is option B. Okay, so this is very simple. Yes, no? Right, you just multiplied two terms. Now will this force be equal to the weight of the rocket? In last question, this was equal to weight of the rocket. Now will this force be equal to weight of the rocket? Yes, no? Okay, answer to this is it depends, right? It's not given to us. So if rocket is not accelerating, okay, there are two ways. Rocket might be accelerating upwards, or rocket is moving with constant velocity. Rocket is moving with constant velocity, that means its weight is just balanced, right? So in that case the force will be equal to weight of the rocket. If rocket is accelerating upwards, then this force must be greater than the weight of the rocket, right? So suppose, for an example, rocket is accelerating by a, acceleration is a, so net force is upwards, so net force must be equal to total upward force minus total downward force, F minus mg. So if it is accelerating upwards, that means this force must be greater than weight of the rocket. Okay, this thing is clear? Yes, no? Okay, so by controlling the combustion, you can control this force and you can control the acceleration. Okay, so saying this is at least very simple, right? Okay, so is there any confusion in this? Yes, Vishalini, this is clear. All right, good. Let's see next one. If the force on a rocket moving with velocity 300 meters per second is 210 Newton, then the rate of combustion of the fuel is, tell me. If the force on a rocket moving with the velocity of 300 meters per second is 210 newtons, then the rate of combustion of fuel is. Option C. Okay, so here there is a catch. I will tell you what. So force is equal to, we know it's dm by dt multiplied by v, right? So now they should have mentioned that velocity of the burning fuel. Okay, but as the sentence is written here, it seems to be velocity of a rocket, right? Correct me if I am wrong. If the force on the rocket moving with the velocity of 300 meters per second, so rocket seems to be moving with 300 meters per second. Okay, so it's not the speed of rocket, right? Are you getting this? Okay, so now, so we'll assume that this is speed of this moving the combustion fuel, okay, which is coming out of the rocket, and then this thing will be the option C that you said, it's correct. Okay, speed of the rocket you cannot find out using this information, right? Speed of the rocket cannot be found using this information, okay, or using this formula also. So you will need to solve the equation that there is some force acting on the rocket, initial speed is 0, then for how long that force acts, if the force is constant, if the force is changing with respect to time, etc., etc., those things are there. So this thing in this formula is what? This is the speed of combustion fuel, okay, fuel which is coming out, ejected fuel, right? Fuel means what? Exhaust gases. This is not the speed of rocket, okay. But anyways, let's put the values. If the force on the rocket moving with velocity of 300 meters per second, so it shouldn't be the rocket, okay. So I am just cutting this and I am just writing the gas moving with the velocity of, gases moving with the velocity of 300 meters per second, okay. So I am correcting the question, right? So then dm by dt is, yeah, you need to find out that, no? So force is 210 and velocity is 300. So dm by dt would be equal to 210 divided by 300. How much is that? 0.7, no? Okay, this thing is clear? Yes, no? Whatever I said right now, right? Good. All right, so let's move on to the next one. Sand is being dropped. This is again similar kind of question. Sand is being dropped on a conveyor belt at the rate of m kg per second, okay. The force necessary to keep the belt moving with a constant velocity of v meters per second will be, tell me. So you have conveyor belt, so this is a belt, it moves with some velocity, keeps on moving with some velocity, let's say v meters per second, okay, and to move that you need to exert some force. So there is a motor which is rotating it, so it will exert some force, let's say. Okay, so let's say there is some force, right? So now there is some mass of this conveyor belt. So if mass is constant, you will need to keep on exerting same force, okay, to keep it moving with the same velocity. Why do you need to exert a force? Because there would be friction, because of which it will stop. Okay, so it is balancing the friction. But now suppose you drop some extra mass. So what's given here? Some sand is dropped. So some sand is dropped here, okay, and it is dropped at constant rate. What's happening then? Its mass is increasing, right? And that's why the force that you need to exert, it will be little bit extra. How much? Tell me. How much force do you need to exert? No, it's not 2 times. Okay, so force is just equal to dm by dt multiplied by v, because you're moving it with constant velocity v, okay. So we are neglecting the earlier force, right, because force due to friction and the force due to the motor, it will balance out, but you are dropping some extra mass. So to keep it moving, what do you need to do? You need to exert some extra force. That's what we want to calculate, okay. So dm by dt is given, it's m kg per second, and then velocity is v, so it is just mv, right? This thing is clear? Yes, no? Okay, so very simple question, right? Okay, so this is similar to the rocket question, okay, based on same concept. All right, then let's see this one. A satellite in force-free space sweeps stationary interplanetary dust at the rate of dm by dt equal to alpha times v, where m is the mass and v is the speed of satellite and alpha is constant. The acceleration of the satellite is, tell me. A satellite in force-free space sweeps stationary interplanetary dust at the rate of dm by dt equals to alpha v, where m is the mass, okay. So see, you have a satellite, option D. Yeah, let's check. So satellite is moving with some speed and dust falls on the satellite, so it sweeps out the dust, okay. It moves through the dust with speed v, and it sweeps out the dust at the rate of dm by dt equal to alpha times v. So what would be force exerted, force by satellite on the dust? Let's call it fd. It's equal to dm by dt multiplied by speed, okay. So what is dm by dt? That is alpha times v, okay. So whatever speed with which the satellite is moving, so suppose initially the dust is stationary, now the dust is collected on the satellite, it moves with the speed v, right? It also moves with the satellite with speed v, that's why this v and that v will be same, okay. So you have alpha times v square. This is force due to dust. Now how much would be, sorry, force due to satellite on dust, how much would be force due to dust on satellite, it's equal and opposite, right? So force on satellite is equal to minus of alpha times v square. Okay, and this force is what? It is mass of satellite. Mass of satellite is capital M, right? Mass times acceleration is minus alpha times v square, and therefore acceleration is equal to minus alpha times v square divided by its mass. Yeah, so Yamini said option D, right? It is correct. Okay, so this is clear? Yes, no? Okay, so now very recently there were no questions based upon this concept, but you never know what questions would be asked, right? All right. Okay, let's see next one. A cricketer catches a ball of mass 150 gram in 0.1 second moving with the speed of 20 meters per second. Then he experiences a force of, tell me. This is very simple, right? It is force is mass times acceleration, m times v minus u divided by t. Okay, so this thing is 150 grams, 150 into 10 raised to minus 3. Velocity is, final velocity would be 0. So 0 minus 20 divided by time is 0.1. So that is, take this in numerator, so it will be 10, right? This is 10 raised to minus 1. In numerator, it's 10 raised to plus 1. 10 times this thing is 10 raised to minus 3, so 10 raised to minus 2. So 150 times 20, how much? 3000 into 10 raised to minus 2, that means 30 Newton. So this is force acting on the ball because the ball stops. Okay, its final velocity is 0. So force exerted by a cricketer or hands of cricketer on the ball is this much. Force exerted by the ball or force experienced by the cricketer would be plus 30. That would be plus 30 newtons. Right, this thing is clear? Yes, no? Okay, good. In this one, yes?
Yes, sir.
So force by a satellite on dust would be this one. Okay, and force due to dust on satellite, it would be equal and opposite. Or you can think of it this way. See, now satellite is moving. If some mass is collected on the satellite and satellite is moving through that mass, it is resisting it, no? So its acceleration would be negative.
Okay, sir.
Right? Good. All right. So this one was very simple. This question is simple. Let's see this one. So this is just for the sake of checking concepts or just moving through the concepts, you can say. Okay, I don't expect this question in 2024. A particle of mass m is moving. Oh, we haven't seen impulse, no? Okay, let's see impulse first. All right. Next, let's talk about the impulse next. So now see, there are some forces which act for very small time and they bring out very large change in momentum. For example, if we think about the game of cricket, okay, so nowadays there are very fast cameras and we can calculate the force due to bat acting on the ball, right? Because we can find out the time for which it acts. okay, but earlier this wasn't the case. So suppose, for an example, let's take a very fast bowler. Okay, anybody knows? All right, I will take an example of Shoaib Akhtar. He used to be fastest one till date. I guess he was the fastest one. So he balls at the speed of 150 kilometers per hour. Okay, the ball comes, hits with the bat, and let's suppose the batsman, okay, let's take our Rahul Dravid. Okay, he exerts a force like this. Okay, so let's not take typical Rahul Dravid, because he will just place his bat like this, okay, angle down, and the ball will come. He will the ball will hit on the ground, and it will even not go to the Shoaib Akhtar, right? So this was the comment made by him. It was most frustrating to ball Rahul Dravid, because the ball will even not come, even it won't come back, right? So let's say that he keeps his bat like this straight. So ball comes with the speed of 150 kilometers per hour, and it goes back with the same speed. But now the time for which this thing is acting, the force is acting on the ball, force due to bat on the ball, it's very small. The change in momentum is very, very large, because see, if this is the bat and the ball hits the bat and goes back, so you can say that initial velocity is in left direction. Okay, so you can say this is minus v and this is plus v. So how much is change in momentum? So it is final momentum mv minus initial momentum minus mv. Okay, so this is change in momentum. This is final momentum, this is the initial momentum, right? And it's equal to 2 times mv. So this change in momentum is very, very big. Okay, and it's brought out in very small interval of time. So this kind of force which acts for very small time and brings out very large change in momentum, it is known as an impulsive force, right? It is known as an impulsive force. Okay, so now what is impulse? So for impulsive forces, we cannot calculate the force. Nowadays in this case we can calculate, because we know for what time that force acts, right? Earlier those fast cameras were not there. Okay, but we can calculate the effect of force. What is the effect of force? It is change in the momentum, right? What is the effect of force? It's change in the momentum. Okay, so what is impulse? Impulse is just average force multiplied by time. Okay, impulse is average force multiplied by time, right? So what is the average force? It is just final momentum minus initial momentum divided by time. So time and time gets cancelled out. So impulse is just change in momentum. It's equal to change in momentum. This thing is clear, everyone? Okay, we can define impulse as average force multiplied by time. Okay, then it comes out to be equal to change in momentum. Now suppose the force is constant like this, okay, and you want to find out impulse. So you are given with force time curve, and from there you need to find out impulse. What will you do? So from the force time curve, suppose I want to find out change in momentum. What will be change in momentum? So here you can say that force, yeah, area under the curve. Very good. So impulse is average force multiplied by time. Okay, so here force itself is constant. So if I want to find out impulse from time t1 to t2, it will be this force multiplied by time. So it is the area under the curve, right? It is the area under the curve from t1 to t2. So force multiplied by time difference from t1 to t2. Okay, so it is area under the force time curve. Now if the curve is not constant, it's not a straight line like this. Okay, if curve is like this, something like this, then how do we find the area? So we have learnt it in mathematical methods, right? So area under this kind of a curve is found using the integration. right? So it is found using the method of integration. Okay, this thing is clear. Okay, good. So then let's see problems based upon impulse, and if time permits we'll come back to, I think it will not permit, but let's see. Okay, so a particle of mass m is moving with uniform velocity v1. It is given an impulse such that its velocity becomes v2. The impulse is equal to, tell me. It's option D. Okay, it's change in momentum, right? M into v2 minus v1. So I was saying we will not expect this kind of question in 2024. Very, very simple, right? Okay, let's see next one. A ball of mass 0.15 kg is dropped from a height 10 meters, strikes the ground and rebounds to the same height. The magnitude of impulse imparted to the ball is, tell me. A ball is dropped from height of 10 meters and it strikes with the ground, comes back, bounces back to the same height. So what is the impulse imparted to the ball? So ground is exerting some force. Okay, some impulse is imparted. How much of impulse is imparted? So let's say this is the ground, ball falls from this height. Okay, so it hits the ground and goes back to the same height, right? So its initial velocity, what would be its initial velocity? Let's take initial velocity to be negative. U is equal to, tell me. So option C. Okay, we'll check that, but what is U? If it falls from some height, U is equal to 10 root 2. Okay, height is 10. All right, so it is root 2 gh, right? So we'll take this as negative and it rebounds with some speed, let's call it v, and if it goes back to the same height, then v and u must be equal. That means no energy is lost, right? So v is equal to root 2 gh. Okay, so what is v minus u, or what is impulse? So impulse J is equal to mass multiplied by v minus u, and that is equal to root 2 gh minus root 2 gh. So m multiplied by 2 times of root 2 gh. Now put the values. So you have mass is 0.15 multiplied by 2 multiplied by root 2 gh. 2 times of 10 into height is also 10, right? So this is 10 root 2. Okay, so 10 times 0.15 is 1.5 times 2 is 3. 3 multiplied by this thing, root 2. So 3 times root 2 is 1.41. Yeah, so option C is the answer, correct. 4.2 kg meters per second. This much is the impulse, right? So this is quite recent question, 2021. Simple. Okay, good. Then let's see next one. The force F acting on a particle of mass m is indicated by force time graph as shown. The change in momentum of the particle over the time interval from 0 to 8 seconds is. So this is the force time graph. How much would be change in momentum? So change in momentum is equal to impulse, and from the force time graph it is the area under force time graph, right? So tell me how much is it? Okay, this is a triangle. You can find out its area 12. Okay, let's check whether it's 12. Okay, Vishalini said 12. So area of this one will be half of base into height. Area of this one is 3 times 2. This is 6. This area is 6. This is 6. How much is this? This is 3 times 4. This is 12. Right, so 12 is correct. Okay, so everybody took this area as negative. Okay, so see, this is a signed area. Very good. Okay, so let me just tell, because everybody, I guess everybody has not answered. So this is a signed area under a curve, right? So this side is positive, this side is positive. So area above the x-axis would be positive area, but this side is negative, right? This variable, okay, force this side is negative. So this is negative area, right? Negative times positive is negative. So this area would be negative. So this is a signed area that we need to take. So area of this triangle is what? It is half of base into height. That is half of 2 into 6 means 6. So area of this one is 6. Area of this one is what? Minus 3 times 2. So that is minus 6. Okay. And area of this one is 3 times 4. Right. From 4 to 8 it is 4. So it is just 12. So total area is 6 minus 6 plus 12. Total area under the curve is 6 minus 6 plus 12, and that is 12, and that is 12 Newton seconds, and that's why the change in momentum is that much, right? Okay, so again this is also a simple question. Let's see next one. The force time ft graph for linear motion of a body initially at rest is shown in the figure. The segments shown are circular, so they have explicitly told us that these segments are circular. They may not tell this. Okay, the linear momentum gained in 4 seconds is, tell me. Okay, tell me how much would be the linear momentum gain in 8 seconds. Momentum gained in 8 seconds. Yeah, exactly, it will be equal to 0. Good, because this area is negative, this one is positive. If you add it up, the total impulse is 0, right? Total impulse would be 0, but you want momentum gained in 4 seconds, so it is just this area. Okay, so impulse from 0 to 4 seconds is equal to what? That area, this area. So that is equal to half of area of a circle. Your option C. Okay, half of area of circle, half of pi r square, and r is equal to 2. So half of pi multiplied by 2 square. So that is 2 pi, right? So option C is correct. Good. So this is very simple. Let's see next one. So again this is similar question. A particle of mass 2 kg is initially at rest. A force acts on it whose magnitude changes with time. The force time graph is shown below. Okay, this is the force time graph, and you want to find out the velocity of the particle after 10 seconds. It is starting from rest. Okay, so this is force time graph. It will give you impulse, that is mv minus mu. It's equal to area under this curve. So what is this area? Area of this triangle is half of base into height, half of 2 into 10, plus area of this thing is half of 2, not half, it's just 2 into 10 because it's a rectangle. Now this is, what is this thing? This is a trapezoid or trapezium. What is the area of trapezium? Do you know area of a trapezium? Okay, let me tell you. So this question is just knowing about that area, nothing else. Okay, otherwise it's similar to the other questions that we saw. Half of sum of parallel sides multiplied by h. Very good. Okay, so if trapezium is resting like this on this base, I would say it is half of area of trapezium is just half of sum of parallel sides, sum of parallel, or let me write parallel, half of sum of parallel sides multiplied by, if it is resting like this, we'll call it as a base. If it is kept like this, then we can call it a height. Okay, so height or base, right? So here, how much is it? So this is 10, this is 20, 10 plus 20 divided by 2. Okay, so plus you have 10 plus 20 by 2, that's sum of parallel sides by 2 multiplied by 2 from 4 to 6, and then from 6 to 10 means it is 4. So again plus half of that area of the triangle, half of base into height, so 4 times 20. Just add it up and you will get the answer. So this thing is 10, this thing is 20, this thing is 30, okay, and this thing is 40. Okay, 10 plus 20 plus 30 plus 40, right? 60, 100. So you found impulse, it is 100 Newton seconds, and the mass of the body is 2 kg. So how much would be? So initial velocity is given to be 0, right? So mv is equal to 100, and that's why v is equal to 100 by m, that is 2 kg. So 50 meters per second, that's the answer. So nothing difficult, right? Okay, let's see next one. A body of mass m hits normally a rigid wall with velocity v and bounces back with the same velocity. The impulse experienced by the body is. So we have seen this one, right? It's just like the ball hits with the bat and comes back with the same velocity. So how much is the impulse? It is not 0. Okay. Option C. Yeah, very good. It's option C. All right. So see, this is a wall, suppose, and a body. Let's take a ball which hits the wall. So suppose its initial speed is u, or initial velocity is in this direction. It hits the wall and comes back. So it goes like this. So this is the final velocity, right? So this one you can say it's v. Initial and final velocities are equal in magnitude. So initial is minus v, you can say, and therefore what is the impulse? J is equal to m into v minus u. So that is m into v minus v. Okay, so that is plus v. So it's 2 times of mv, right? Okay, this one is simple. This one, yes, tell me. Or did I do a mistake? 30 plus 20, 50 plus 10. No, it's correct, no? Okay, but what did you want to see? in this question? Okay, no problem. All right. Okay, so this is very simple. Let's see next one. A rigid ball of mass m strikes with a rigid wall at 60 degrees and gets reflected. Okay, rigid ball of mass m strikes with rigid wall, okay, and gets reflected. So this rigid means what? The ball will not break and the wall will also not break, right? Rigid means the body's shape and size will not change. Okay, rigid body means the body whose shape and size remains constant. Okay, it doesn't change due to the impact of force. A rigid ball of mass m strikes with rigid wall at 60 degrees and gets reflected without loss of speed as shown in the figure. The value of impulse imparted by the wall on the ball will be. Okay, so here see, it is hitting the wall at some angle. This angle is 60 degrees. So in this case, what we need to do is we need to resolve this velocity in two components. Okay, so let's resolve it in vertical and horizontal components. So what will be vertical component? So this angle is 60 degrees, means this angle would be 60 degrees, right? This angle would be 60. So this is v cos 60, v cos 60, right? V cos 60, and this component would be v sin 60. Okay, similarly velocity here will have two components too. Okay, so this one is, so this angle is 60, means this angle is 60. So this is v cos 60. Okay, and this component is v sin 60. So here you can see what happens to the vertical component of velocity. Vertical component remains constant. Okay, and what about the horizontal component? Horizontal component is also constant in magnitude, but it is reversed in direction, right? So net force is in horizontal direction only. Okay, and what is impulse? What is the impulse then? So impulse is also in horizontal direction. So J would be equal to, let's say Jx, it is v cos 60, sorry, m into v cos 60. But if you call this one as positive, this direction as positive, then this one you will need to call it as negative. Okay, so v cos 60 minus v cos 60. So again that is, you can take cos 60 common, so v minus v, that is plus v. So 2 times mv cos of 60. So what is cos 60? It's equal to half, right? So 2 times of mv multiplied by half, and that is 2 gets cancelled. So mv is the answer. It's option A. Okay. So somebody told the answer. I guess Vishalini. Okay, you did the same thing. Okay, good. This is clear, everyone? Right, good. So in this kind of an example, so just remember that vertical component remains constant, and then what do we need to do is just find out horizontal component of velocity, and the impulse will be 2 times of m into horizontal component of velocity. Okay, so impulse, just remember Jx would be equal to what? if wall is vertical, of course, right? So Jx would be equal to 2 times of m into Vx. That's it. Okay. Let's see next one, which is similar to the other one. A 0.5 kg ball moving with the speed of 12 meters per second strikes a hard wall at an angle of 30 degrees. Okay, strikes the hard wall at an angle of 30 degree with the wall. Okay, 30 degree with the wall. So it's similar to last one. It is reflected with the same speed at same angle. If the ball is in contact with the wall for 0.25 seconds, then the average force acting on the wall is. So impulse is equal to change in momentum, right? So it is mvx minus mux, and that's equal to 2 times of mvx, as we just saw, right? Because vertical component will not change, vertical component will remain constant, and this angle is given. This angle is 30 degrees. So if this angle is 30 means this is 60. Okay, so how much is this thing? So it is 2 times of, so change in momentum, it is equal to 2 times of mvx. This is equal to delta p, I will say, and this is you want force, no? So force is equal to delta p by time delta t. So it is just 2 times mvx divided by time delta t. 24. Okay, let's see. So it is 2 times of mass of the ball is 0.5 multiplied by speed was 12 meters per second, but you don't want that 12 meters per second, you want the horizontal component. What's the horizontal component? If this angle is 30 means this is 30, so this is 60 degrees. Okay, so 12 cos 60 or 12 sin 30, you can say, right? Because this component is, this angle is theta, 30 degrees. Okay, so this will be 12 cos of 30, this will be 12 sin 30. Okay, so that is Vx. So 0.5 multiplied by 12 sin 30 divided by time is 0.25. Okay, so this thing becomes 1, 2 times 0.5, then this thing is half. Okay, so then the 2 comes in denominator, so 0.25 times 2 is 0.5, 12 by 0.5, right, it's 24 newtons. Correct, option C. So this is simple. Right, good. Then this thing is repeated. Okay, so the good thing is that this one is repeated. Okay, so a body of mass 3 kg hits a wall at an angle of 60 degree and returns at the same angle. The impact time was 0.2 second. The force exerted on the wall. Tell me. So similar to last one. Here this angle is 60. Okay, so let's find it out. This angle is 60. So this one would be 30. Okay, this one is 30. Theta is 30. So Vx is V cos 30. Right, and how much is the impulse? You don't want impulse. Change in momentum, change in momentum, which is equal to J, it's in x direction, so Jx, that's equal to what? 2 times of mvx. Okay, and therefore force is equal to delta p by delta t, that is 2 times of mvx. Vx is what? V cos 30 divided by time. So put the values. So 2 times of m is 3 kg multiplied by V is not given. Impact time is given. Oh, it's given here. V is 10 meters per second, right? It is given here. So 10 multiplied by cos of 30 degrees. So cos 30 is what, root 3 by 2, and divided by the time is 0.2. So 2 gets cancelled. This is 30 divided by 0.2, or 2 into 10 raised to minus 1. So that's 15, 150, okay, 150 root 3. So that's the answer. Okay, this is very simple. Okay, good. Then okay, then it is based on some other concept. It's 8:30 already, 8:35. So we'll stop here. Okay, and I will forward the worksheet on this thing, and I will tell which problems to solve, right? Okay, are you solving the problems? Okay, good, very good. All right, so let us stop here. Have a good day. Okay, bye.